So, how do we do this balancing equation? We have time to run through one. Let's go here. Okay? So here's what we do. Okay? You don't have to do it this way. If you see how these things work together, that's okay. This is one way that you can do it. Alright? We go here, we go here, we go here. Okay? So, here is our equation. First thing we do, right underneath the arrow, and like I said, you don't have to do it this way. You can balance equations just by seeing your head, that's fine, but you need to know how to balance equations. This is the way I teach it. Underneath the arrow, let's write the symbol of all of the elements that appear in our reactants. Okay? So there's some nitrogen atoms in our reactants, there's some hydrogen atoms in our reactants, and there's some oxygen atoms in our reactants. So I write NHO right underneath here. Okay? Now, we should see that those same elements also appear in the products, right? If we don't see something in the reactants and it ends up in the products, or vice versa, if we see something in the products it's not in the reactants, we got something wrong. Okay? But do we see any other symbols over on the product side other than the three that we wrote on the reactant side? No. So here's what you do first. To the left of this, let's count up how many of each type of atom is over on the product side. Okay? So do that real fast. Count up how many of each type of atom are over on the product side, and then just write their numbers right here next to their symbols. Sorry, reactant side. Sorry. Count up how many of each type of atom are on the reactant side. You can probably end up guess where we're going next. Good.
And we can figure this out without doing it. Do we have to show it work?
Like I said, as long as you can balance equations, that's okay. Okay. You just need to make sure you can balance.
I like Obama.
All right. So there's that. Okay. Then do the same thing, but do it on the product side. Right. So if we do the same thing, 2, 2, 1. Everyone see where I got those numbers from?
Yeah.
So, first question. Is this equation balanced? No. There are not the same number of each type of atom on the left and on the right. Okay? So, what do we have to add here? Okay, so the 2 in front of the H2O, Joe, we call a what? Coefficient. So by throwing a 2 out in front here, okay, throwing a 2 out in front, right, this coefficient applies to the entire molecule. We're basically now saying, okay, we're going to make 2 molecules of water. So within 2 molecules of water, how many hydrogens do we have? 4. Okay. So now this changes to 4. Right? And then, right, what about the oxygen? That goes from 1 to 2. Okay? Is this a balanced chemical equation? Yes. Okay? We didn't change any of the subscripts, but by adding coefficients in front of the subscripts, we've made the same number of atoms left and right. Okay? With that being said, no. This coefficient applies to the entire molecule. So by doing this, we're doubling the hydrogen, we're also doubling the oxygen. Hey! Can't do it that way. Got to find some other way to do it. Alrighty. If we take a look at the calendar, there are a couple of reading assignments that I got for you here. Page of your book. Okay. The last one is about balancing equations, and then there are a couple of questions dealing with balancing equations from your book. Probably a good idea to take a look at them, even though we didn't do too much balancing equation practice. Tomorrow we will do a lot more balancing So we'll start there tomorrow.
Can I have like the last